We will now do exercise 3. So notice what I've done. Instead of having the block down like this, I've moved it up on its side. This has to do with the concepts of pressure. So the total normal force is still the same. Remember, the mass of the block is 210 grams. It's 210 grams whether it's like this or like this, correct? So the mass of the block is still 210 grams, so the normal force is still 210 grams. Now, move it up like this. What's the mass of the block? Still 210 grams. Normal force is still the same, 0.210 times 9.8. So again, the normal force, 2.058 newtons, you should have calculated that out. 0.210 times 9.8, you should have done that in the previous 2 exercises. So you already know that the normal force for this particular block is 2.058 newtons, or 2.06. That's 3 significant figures. So, oh actually, no, you have to do 2.058 because it's 4 significant figures. So what we're going to do, first of all, what I've done is I've adjusted the pulley so the string is horizontal, the hook is a little bit higher. Then what I'm going to do is the same thing I did in the previous exercise. I'm going to put mass on the end of the mass hanger to see, and push the block to see if it goes at a constant speed. Right now it's not moving, so obviously we have to put more than 50 grams on there. So I'm going to put 20 grams on there. Then I'm going to push it and let's see what happens. Looks like, let's see, I think it may be going a little bit too fast. Maybe accelerating, oops. Oh, it's definitely accelerating. So 20 grams is too much. So what I'm going to do, I'm going to take off the 20 and put a 10 on there. No, actually this was 10 grams. I lied, that was 10 grams. Let's put a 5 on there. Let's see if this works a little better. That's better. Okay, so that's a good measure. Now let's turn back our scale, which has got to go through its initial setup, and put whatever's on top. It should be 55.3 grams. 55.3 grams. So you can see it's quite close to our first exercise. So for this one, when it's on its side, a smaller area, the normal force still is the same. So it shouldn't make that much of a difference. And if you go look back in exercise number 1, let's see, it looked like there was 60.1, so it was close. This is 55.3. So now what we're going to do is the same thing, except we're going to do the static case. Now again, this is probably going to be a little bit more varied because the static is always a little harder to do because of the differences. Now, technically the surfaces aren't exactly the same. I know it's wood on wood and still pine, but if you take a look at the surfaces, the plank is the same. But notice the surfaces of the wood. Notice if I move it on the side, it looks different on its edge. It looks different than its side. And that's because this way you're looking at some of the edges coming right out. You see it looks different this way than that way. So the coefficient of friction is going to be slightly different, but it should be relatively the same. There's a small difference, so we shouldn't be horribly alarmed if it's that different. So I'm going to put 50 on there. Oops, and it moves. Okay, so 50 is too much. I'll put 20. All right, that's it. So let's go and mass it over here. 90.2 grams, 90.2 grams. Okay, well, 90.2 grams, and that's for the static case. Now before, if you look, it was 100.3 grams that was required. So again, it's a little bit of difference than the second exercise when we did the static. But it's quite close. And find the percent difference. It's probably 10 to 20%. Just, again, the surface isn't exactly the same here. I mean, what we could do is try it on the other edge. Why don't we do that just for the heck of it? Instead of having it up like this, let's have it up like that. Why is it stained like that? It looks like it got wet or something. Let's go see if it's exactly the same as it is. Okay, now this time it's not moving. So you can see that I'm having exactly the same amount as I did. It made the other side move, but this side it's not making it move. Let's put a 20 on there. Oh, and it moves, okay. So that is actually quite interesting. Each of the sides have slightly different coefficient of frictions. That's not completely unexpected. So now what we're going to do, find the coefficient of friction in each case. You know by this time how to find the normal force. We already know the normal force is 2.058 in each case. However, the frictional force, what you do is you take the mass, 0.0553 times 9.8, and then 0.902 times 9.8. Then that'll be the frictional force. To find mu, you have to take the frictional force and divide it by the normal force. F equals mu n. So to find mu, you take F divided by n. Then compare that with exercise 1 and 2, respectively.